Good morning. My name is Jim Fawcett. Today we'll be talking about publishing source code, and we'll be doing that through a website, and a lot of our discussion will focus on the nature of that publication, web-based publication process. So let's begin. We're going to start by talking about software salvage and reuse. Our intent is to provide access to a series of components, and the intent is that these components are building blocks that will be used to that will be combined in ways to build interesting systems. And so we'll be reusing. The intent is to publish these components to be reused in that way. We'll talk quite a bit about the repository structure that we're developing to implement that publication process. We'll talk a little bit about quality control for the contents. We'll talk about some experiments we're doing to try to make the publication process effective. And then we'll talk about some conclusions. So let's start with software salvage and reuse. We're trying to publish software components, that is, a building block for larger systems. And a component typically is a software package that is focused on a single activity, doesn't have many dependencies, and is structured in a way whose functionality is such that it's useful for building software systems. And that can happen in a couple of forms. That building process can happen in a couple of forms. One is software salvage. In Salvage, we take a component that we want to use in the system, and we modify it to suit our needs for that particular system. And that's good, but it creates, now we have two components. We have the original component, and now we have this new modified component that has to be configured and managed, and we have to make a distinction between, you know, which is the original, which is the new one, how do they differ, and so on. Reuse with no modification. Reuse means using existing components with no modification, and that's a really good use case because we don't have, we didn't create a new component to be configured. So how do we do that? We compose that new component with other parts of our software, class, for example, class member. We use it as a template argument, or if the component itself is a template class, then we'll configure it with some application-specific type, or we'll use it as a base class for derived classes. All of those are good ways of reusing code without modifying them. And we want to do that because we want to improve productivity. Developing software is a very labor-intensive process. Anything we can do to make that more productive is a win, and that's exactly what we're trying to do. The other aspect of that is any code that we don't write won't introduce new defects or performance issues. You know, so the code that we are reusing has to be designed to be as free of defects as we can make it and have good performance. But you know, if once we're there, we reuse it, then it's a you know, a win situation where we're more productive and we're not introducing new defects in our code. Okay, so software use has a good news, bad news history. The compiler libraries have been extraordinarily successful in providing software reuse. The C++ standard library, the .NET libraries, the Java packages, and so on have been extraordinarily useful. the technology wouldn't be what it is without that. That process works very, very well. What we're trying to do is extend that advantage to domain-specific code that's not part of a generic computer language library, but for academic or industrial or commercial domains. And so far, that reuse has often been disappointing. A typical scenario is we want to develop a new system. We look for a system that's as close to what we want to build as we can find, and we try to tear out the parts we aren't going to use. And we don't, sometimes that causes a lot of breakage, and we might even elect to leave the parts that we're not using in just to avoid all that breakage, but then that causes maintenance problems because a maintenance developer has to decide, is this code being used or not? And, then we have to merge with new code and, add new parts, and we just spend a lot of time fixing breakage. So not a necessarily a happy situation. That's what we want to improve on. Domain candidates are academic research. It's very typical that, especially in the computer engineering, computer science areas, academic research involves developing fairly big software systems associated with it. That's also true of mechanical engineering, fluid flow, processing, and so on. So, but research, if this is scientific research, one of the yardsticks against which it's measured is can we replicate those results? Are they, do we trust them? Can we say, yeah, I verify that really is the case? Well, if this is a software-intensive system and we don't have access to that code, no way we can replicate the experiment. So, opportunities there for publishing parts. Now, understand that there are, in academic research, there's going to be a period of time where that code is highly proprietary, and we wouldn't make it, we wouldn't publish it publicly, but we would publish it within our internal research group, and our faculty advisor may well have colleagues in other universities with groups that are working on similar problems and collaborating together, and so we might well want to share some of that code with those teams. Once we've completed the research and published our papers, now we want that research to be, we want others to be able to replicate that research, and so we'll make that code publicly available. That's the model, a model we're trying to support here. Not widely used, but there's a good reason to use it. Open source development is an interesting domain. Their model is quite different than us. They already have a very effective, in most cases, a very effective publication model. But what they're trying to do is different than what we're doing. What they're doing is their individual developers are uploading code to a development baseline, and then what they're publishing are complete systems, the Linux system or Node.js platform or something like that. So they're not trying to publish individual building parts, they're trying to publish a completed product. Industrial and commercial development, clearly opportunity for software reuse. Machine tool control, for example, the machine tool platform, probably the basic platform will stay relatively unchanged for 10 or 15 years, probably. Minor improvements, but essentially the same. And the code will have that same kind of lifetime, but there will be, each new product will generate additional functionality, new ways of programming the machine tool, tighter control over what it's doing, and so on. So here we also have a situation where software reuse would be really valuable. In aerospace programs, this is an aerospace companies are big. It's a very rich development environment, lots and lots of stuff going on. For individual teams within aerospace, for example, I worked in radar for a number of years, and we had teams that would work on signal processor and radar control and target data management and operator interface and so on. And each one of those teams would be developing code to combine with their colleagues. But once a product was delivered, then it's very likely that additional contracts will be let, and we'll be developing more products very, very similar to this original product. You know, some changes, but maybe 50, 60, 70% of the functionality would be the same. And so lots of opportunities for software reuse. Okay. So how do we support this? So we want to, again, just to reiterate, we want to provide application domain specific code, the same advantages we get from compiler library reuse. In order to be reused, the component has to be designed so that reusing is possible. That, you know, it's quicker and easier than creating the component from scratch. There's lots of good examples. The standard C++ template library and Apache components are good examples of that. And the technology now, the languages are, most of the popular languages is straightforward to build reusable components. And, you know, there's some details there. That's a topic for another story that we'll get into some other time, but imminently doable, but you have to design for that. The components have to be available. You got to have some way of accessing them, and that implies some sort of cloud-based repository. In our case, we're using GitHub, which is a fine example of a delivery mechanism. And the components need to be documented. You know, what's the concept? How do we, you know, what's its intended use? Can you show me some examples of how it's used? You know, show me some code where it's being used. How did you design it? You know, what are the details? What's its current status? All of those are important things for documentation for something you want to reuse. So now I want to turn to the website we're developing to support reuse. And I've given a link here. We'll take a peek at it later on. This is this website is a second generation. For years, I taught a series of software design courses out of this website that's highlighted here, and all my lecture content was contained in that website, and sample code and so on. You know, we're publishing sample code. But over the course of a number of years of using that, I felt that the process I had implemented for publishing code was suboptimal. It worked. Classes, you know, students could find my code. They used it in their courses. You know, I wanted them to have code that would allow them to build really ambitious projects, things that were more interesting than things that they could, if they had to build all the code themselves. So, so that site worked, but it was imperfect at best. And so I set out on this quest of developing a better mousetrap for software publishing, and that's what we're going to talk about right now. So, so we want to improve on that original site's process, and the aspect, you know, publishing some code artifact is making it available in some usable way, and there's issues associated with each of that: containment, delivery, location. How do I find something in a large collection? When I found something, how do I interpret it? You know, figure out what it does and how I can use it. And how do I maintain the quality of this repository? These are all questions we're going to address right now. So containment and delivery, they're solved problems. The cloud-based facilities like GitHub do that very, very well. In fact, we're using GitHub as a basis for our publication process because we didn't want to reinvent. It already existed. It was just fine, thank you. That doesn't need improvement, at least not in any major way. So the issues for us are finding and understanding code that we might put on a site like GitHub so that people can find something that's relevant to a need they have. We want the collections to be large to support broad reuse. You know, we want the probability of somebody finding something they want to be high, and that's only going to happen if we have a large collection. So how do we find in that large collection code that fills some need? So a good option is to have website documentation co-located with the source code and a very carefully thought out navigation process. So that's where we're going. So for publishing, we'll need a structure for holding the collections of code, a navigation process that people can understand that isn't so complicated that they're totally baffled in order to find code and resources, documentation for each of the components, you know, what's its concept, design, usage, and so on. And we'll probably want to make some additional resources available to help people understand the technologies that are used to build these components, you know, language and platform references. And we've provided some what I call code snaps or snapshots of code. They're basically web pages. We've taken source code and turned it into a web page so they can quickly see it without, you know, downloading it and loading it into an IDE and then looking. You know, we want that process to be really quick. You know, we can't do it for everything in a site. That would be overwhelming, but for key examples, we do that. And then we want to provide, you know, some blogs and opinion pieces and stuff like that, just for background, you know, background for this process of publication process. And we need code standards. And by code standards, I'm not talking about some big, complicated document. Here, what I'm really thinking about here is a very brief, maybe a short one web page standard for what does this code component have to, what attributes does it have to have in order that we will accept it into this repository. So I'm not talking about code standards that an individual developer would use as they write code from scratch. I'm talking about what, you know, what properties this component need to become a full-up member of the repository. And then, you know, we'll want some stories and videos and things like that to augment that collection. So here's the structure. We have a, you know, this is an index page, and in that index page there's a menu system, and the most important thing are the repositories. So here's a link to the repositories right next to the home, and it comes down, and here we have each one of these. This CPP repository is a table of all of the repositories that are holding C++ code. Now, you know, let's make one bit of terminology clear here. A lot of people, when they say repository, mean a collection of all the code that's available at some site. That isn't what we mean here. We're using the GitHub definition where a repository is something used to hold a project. And so we're providing many, many C++ projects, and then, you know, on the next layer back, maybe many, many C# projects and many, many JavaScript and some Python projects and so on. Probably won't be any Fortran, probably won't be any COBOL, probably won't be any Pascal, but so on. And, you know, so it's a nice organizational scheme. So if I know I want C++, you know, I can come down here, I'll look in the table, and now this page has a menu. It's different than the top menu, and what it has are categories of these components: utilities, tools, components, libraries, projects, demos. And you can see what's here just by hovering over each one. The list drops down. You can see the list. We're going to look at that in just a minute. And it's an effective, really effective navigation strategy. So let's take a quick peek. So here's the website. And now if I click on repos, here we are, utilities. And so here's my utilities and tools and components and libraries and so on. And if I want to know a little more, I go to click on the tools. And so here's a text finder tool. I find out a little bit about what it does. And this links directly to the repository code. And if I go to one of those, so here's the text finder page. If I go to that, I've obscured it, but if I go to that, this link over here is goes directly to the source code. So that's the model. That's the overall structure. So we also have blogs and resources, links to language references and things like that. We have platform and languages, and for example, this is C++. We'll see a screenshot of that in a minute with code snapshots and these just a web page for code, just to give you really quick access to a few selected pieces of code. And as a storyteller, this is kind of an interesting idea, I think. The model of the storyteller is we're telling stories that are collections of an ordered collection of resources from the site that's focused on a single theme and kind of allow the user to, it helps them get started with a topic, helps them sequence through the topic in some sort of rational way. And when you get to the end, the user knows that he's probably exhausted all the resources on the site available on that topic. So, nice ideas. Okay, so this is just the definitions that I gave before, so let's skip over it, just what a repository is. So this is the repository part. Here we're focusing on the repositories. And so the goal is to have large collections, and navigation is the issue. And so our model is that we'll link from the home page to collection. This collections are factored by language or product or whatever you want, however it'll work for your domain. And those, we factor each collection into individual repositories, utilities, tools, and stuff. And we link first to the documentation, and then the documentation links directly to the code folder. So you link to the documentation links to the code folder. So it makes it a really, everything is done that same way. It's consistent, makes it easy, not too much, fairly short learning curve to figure out how to use that. Here's an example of stories. So, just an organized collection of pages on a site and resources, not necessarily just web pages. And what we're trying to do is help them, grapple with the content. So a C++ story would help them with understanding the technology behind the C++ components. That we have a site story, which helps them, just use the site and understand how the site is designed and so on. And we have some guest stories. This one, MLIPS, was an acronym for Machine Learning Integrated with PowerShell. A really interesting story written by a colleague of mine, Mike Corley. You're invited to go take a look at it later on. And this is the storyteller interface. And so if you click on the top menu, Stories, you'll see a story list. And one of those items on the story list is a C++ story. And if you click on the story list, you'd see Mike's MLIPS and the other stories that we have available. So it's just a nice way of sequencing through these stories. kind of a cool idea. These are the code snaps, and the idea here is just that, especially for people who are new to a language or are refreshing themselves, we get a real quick view. We don't have to download code and pull it up in an IDE. We just get a real quick, web-based view. And so what we've done is we've converted stack.h and stack.cpp and so on into a web page. What that means is that it's the code itself is bracketed inside the header and the body wrappers of a web page, and any markup is translated into escape sequences, so it's not interpreted as markup by the browser. And so away we go. If we go here and take a look at this, here's the snapshots. So here's the templates code we were looking at, and there you get a quick view. So nice, just a nice way of getting a quick view of some individual pieces of software. Okay. So quality control. So the issue here with repositories, anybody developing and building repositories, it's awfully easy for the repository to get filled with refuse, just stuff that's no longer valuable. One of the biggest problems with my university website was I taught out of that for 20 years, and a lot of the code, was a piece of code that was appropriate the first 2 or 3 years of my use of that site. It was totally inappropriate because of the technology is out of date and other things have replaced it, but it was still there. I was busy and I didn't do as much quality control on that site as it deserved. So we don't want that to happen. How do we avoid that? So we need an effective structure for disclosing the contents of a repository, and this site has a better structure than my original site did. And then we have to have a willingness on the part of the site sponsor to invest in that review and improvement. We need standards, just a brief statement, nothing fancy, not a big document, just a short web page that says, here's what this component has to do to become a member of the repository. And we need knowledgeable and productive people, a person or two, to evaluate components against the standards and admit or reject. One thing, for example, for industrial development, or commercial development, you might envision a process where a project ends and a few of the more technically oriented members of the team sit down and go over the code and look at what parts should we think about incorporating in a repository, and how do we need to modify them, or do we need to modify them in order to make them reusable components? So anyway, we need, you need to make that investment, and then you probably want to do a continuing background review. Is this component still valuable? And GitHub gives you some really nice tools for that, wikis and charts, wikis to communicate and charts and so on. The last, before we draw some conclusions, the last thing I want to talk about are some tests. So one of the things I wanted to do was to do some experiments to try to make this publication process as effective as possible. So here, we're experimenting with ways of managing screen real estate. So anytime we're presenting technical documents, especially like the documentation for a repository, we have conflicting needs. We have a fairly large amount of nuanced text, that's carefully crafted. But we also have lots of diagrams and stuff we want to show, and they're struggling for real estate. But now the idea here is that we can just expand it or contract it. So now when I want to look at the text, I just make it small. I can make it disappear, and when I want to look at the details, I can pull it way out. Good idea. So slide-in panels, another possibility. Just toggle stuff in. So the model here is that we're presenting information about this page. Might be transition information. It might help us make a transition from the last page we looked at to this page. One of the things that the site does is it uses sequences a lot. So it defines sequences between pages. So for example, a story is a sequence of pages, but also the blogs are a sequence of pages. So I can go next, stepping through the blogs. So this might be a transition, or it might be just some additional detail that a user needs. Now, there's nothing new about, what do you mean experiment? There's nothing new about a slide-in panel. People have been using these for years. But what I'm referring to is we're trying to use this known technology, experiment with this known technology to be as effective as we can. Is this a good use of our controls surface and the view platform? And the answer isn't always yes. We tried some experiments. I'll show you a couple in a minute that just weren't all that successful. Whoops, I didn't want to do that. Let me get back to where I was. So, so now I want to go back to Draggle. I did some experiments. This really wasn't trying to make a component for the site. What it was trying to do is to make sure I understood how to make something draggable both by mouse and touch. All of these widgets that we're talking about now are activated both by mouse and touch because I wanted to support someone using a tablet that didn't have a keyboard and didn't have a mouse associated with it, a tablet to view content on the site. They're not going to create content or download stuff probably, but here's essentially a failed experiment. I thought a splitter bar would be a great idea. I've used them in user interfaces where they work really well. But here, after I tried it in a couple of places, I just thought, it's just not using real estate really well. Either I'm still occupying all this big space and I'm not filling it up with it. I just didn't like the way it worked. So you might like it, but I didn't. So, but here's something that worked pretty well. This is what I use throughout the site. These are clickable images. If I click on most images, you can click on and make them bigger. And if you click on the title, I'm clicking on the body. If you click on the title bar, they get smaller. And if I've made them big, if I refresh the page, then it goes back to the original form. Here, I've added a button handler to this information bar at the bottom that just does a page refresh. That's what it is. So anyway, some of these experiments have been incorporated. Some of them haven't yet, but will. Slideshow was a experiment I did while I was thinking about the storyteller. And I experimented with some code styles and photo styles and stuff like that. So quite a bit of experiment going on. Okay, so and here there is so this, what you're looking at is a presentation. It's not really a story, not really a set of pages. It's a PowerPoint. It's a PDF version of a PowerPoint deck. But I do have a site story that addressed essentially close to the same topic, and I have more information on the experiments and why we did what we did and the observations of those experiments. You might want to look at it. The fact that I'm using both PowerPoint and stories is interesting. I originally thought, gee, I don't need PowerPoint. I'm just going to use stories. But that didn't turn out. The stories tend to be, let me click on the stories so I can tell you what I mean. So the stories tend to be dense. They're really great for reading, but they're not great for presenting. Way too many words for a presentation. Nobody on earth would follow me if I tried to walk through that. So I am using both. So anyway, so now let's draw some conclusions. So where we are, most of the structure that we've talked about is in place. You can get to it from this website. You're welcome to download code from it. We have more than 40 repositories of C++ code. Not all of them are as well documented as I want them to be. Again, I've been working on the site for 4 months, and it'll probably be the end of the year, this year, before I'm happy with most of the documentation, but they're usable, useful. We published several stories. We got some code snaps, and we plan to do more of the same, install more code repositories. And I intend to install a starter site. So the idea here is that not only do I want to serve users by serving up code to them, but I'd also like them to be able to serve their own code. If they're a machine tool control guy, they don't want to, my code may not be relevant for them, but may not be relevant for them at all. So, they might be writing in a script language that has nothing to do with, what I'm doing. So my intent is to put a starter site, a small site having much, much less content than I have, but a good way to get started, just to add, documentation or repositories for an individual project. And yeah, you'll hear more about that. That probably will make its appearance around the end of the year, around maybe the beginning of January of 2020. So this site is a static site. And they have some, static sites have some real advantages. One is that you can deploy them right off your drive on your laptop. The browsers are very happy using a file protocol to load files right off your computer drive, and honor links, and so you can run the website right off your individual machine. And that means, you can tailor it just to your own personal stuff. You're not trying to publish it. You're just trying to publish it to yourself. That's handy. The other thing is that sites like GitHub won't only publishes static sites. And the reason is, static sites don't have any server processing. All the processing with this site, all the menus and widgets and stuff are being processed by JavaScript on the client, not on the server. And a site like GitHub that has millions of subscribers, they can't afford to do a whole bunch of, high CPU processing, handling databases and all that kind of stuff. So what that means is, the implication of that is, if we're using a static site, is that we can't implement from the site search. It's something I'd really like to have, but there's no processing on the server side to implement that search. So I've tried to make the structure self-searchable, but you'd like to be able to automate some of those searches, and we've got some ideas about that. One of them is to construct a mirror with some tools, a tool that just periodically goes to the GitHub site and maybe every day downloads a couple of repositories and just cycles through all the repositories. So maybe in a couple of weeks, it's gone through all of the repositories. And so any search you make, and so we can develop tools to do searching locally, no issue at all with that. And so we can wind up with a very effective search done locally, just because we're mirroring, we're a mirror for that site. So again, we haven't developed those tools yet, but I've thought about them a little bit, and I don't see any reason why. I think they're eminently doable. So they'll make their appearance before too much time goes by. The final conclusion is, is the return on investment worthwhile? Are you getting enough benefit for the effort involved in setting up a site like this? And I think the answer is decidedly yes. This site went from nothing on GitHub to where it is right now in 4 months. I started this 4 months ago. And, in all fairness, I built a site like this, at my SU. So it wasn't, a lot of the ideas were already, known commodities for me, and some of the techniques and stuff were known, and the menuing system I'd worked out there and so on. But all the real content, and there were no stories, there were no, no story reader, no repository structure the way it is. All that was put in place. And, and I think the potential benefit is very big. A aerospace developer is building surveillance radars, I think it could be very useful for them to have parts, building block parts for signal processor code and for, you know, target data management and track association and all those kinds of things that tend to get reinvented or salvaged from existing projects. So anyway, that's my story. I hope you enjoyed it. I invite you to look at some of the other stories, and you know, stay tuned. More stories and more material, more repositories will be coming online. So with that, thanks for listening. I enjoyed talking with you, and sayonara.